Hello everyone, I'm Sunita from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic testing of hypothesis, in this video we are going to see what is difference of mean. That is how to compare the mean of two populations or sample populations. So here is the small recap of the previous video in which we have discussed about the testing of hypothesis of a single mean comes, comes under large sample test. So in that previous video, we have studied what is fundamentals of hypothesis testing and how to frame null hypothesis, alternative hypothesis, and the types of error which occurs that are type 1 and type 2, which are otherwise known as alpha error and beta error. Then we have seen what is level of significance and critical values and how to solve a real life problem as well as the p values. So here are the learning objectives of the current video, which are understanding the concept of difference of two means, next how to apply the concept, next analyzing, next solve the real life problems. So here is the empathy and define part of a difference of two mean topic. So in which a pharmaceutical company develops a new drug to reduce a blood pressure. So they are in need to determine which medicine is good or effective. So therefore they are comparing the mean of the previous medicine which they are suggesting and the new medicine which they are developed. So in this case, they are a need to significantly know the difference between the mean blood pressure reduction of patients using a new drug and the old drug. So they are using this difference of two means topic. So here is the formulation, that is test statistics formula, which is z is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So here the assumptions of this topic are independent random samples. Next, large sample size should be always greater than or equal to 30. Then only we can apply this test. Next is to know the estimated population variances. Then the alternative hypothesis and null hypothesis are framed in such a way that H naught such that mu1 is equal to mu2 as the null hypothesis and H1 such that mu1 not equal to mu2 or mu1 greater than mu2 or mu1 less than mu2 as the alternative hypothesis. Next, decision making is based on Z formula, which is normal distribution. So here comes the problem solving part or the hierarchy. So in which first the sample means are calculated and the difference of two means are calculated. After that, the standard deviations are calculated and the denominator part, the root of sigma 1 square divided by n1 plus sigma 2 square divided by n2 are calculated and everything are substituted in the formula and we get the test statistic result, which is also known as the calculated value. So here is the mind map of difference of two means. So in which first the assumption part is made using H0, H1 and critical value. Next, hypotheses are tested and the test statistics, the formula application part, which is otherwise known as calculation part. And the final one is decision making or decision rules. So in decision making, usually we consider the level of significance. With the level of significance, we'll find the critical value. So with the critical value and calculated value both are compared. So if the calculated value is greater than that of the critical value, then we will accept the H naught, that is alternate H1, which is alternative hypothesis. If the calculated value is smaller than that of the uh, critical value, then we will accept our H naught, which is null hypothesis. So these are the key summary, which are core concept core concept, that is how to use the two means. Next, the statistic formula. Then is the decision making, and this concept is widely used in medical researches, quality control, educational assessments, and business analytics.